Hello Year 12, welcome back to Mathematics for your next stats lesson. We're going to start things off with a revision question as per usual. So this is from the 2020 NESA sample exam that was recently published. This is the second question. It was multiple choice, but you can see what the multiple choice options are. At which point on this curve, either A, B, C, or D, are the first and second derivatives both negative? Have a think. Okay, so if the first derivative is negative, it tells you that your function is decreasing. So straight away, it can't be A or D because it is increasing at these 2 points. They have positive gradients. So it has to be B or C. So which one of these two has a second derivative being negative? Okay, so in my head, a negative second derivative is a frowny face, which means concave down. So C is concave up, we can see, and B is concave down. So the answer is B. Well done if you managed to crack that one. All right, for today's lesson, we are looking at quartiles. Very exciting. All right. So starting off with just what a quartile is. So first of all, a median you're familiar with. A median attempts to split the data set into 2 equal halves. Likewise, quartiles try and split a data set into 4 equal quarters. Of course, this isn't always possible. If you have a data set of 5 scores, you can't really split that into 4 quarters, but it tries again as close as possible. We can also look at deciles. These split the data set into 10 equal parts, and we have percentiles, which attempt to split a data set into 100 equal parts. That's why often you hear people being in like the top percentile as the top 100th, essentially. All right, so here's an example looking at quartiles. We have the number of snacks per day eaten by someone working from home over a 9-day period recorded below. This is real data, guys. It's getting very much out of hand. We have find the final number summary, the IQR, which stands for the interquartile range, and then draw the box plot. So this question revolves around finding your quartiles. Let's just give ourselves a bit more space. Now, first thing we need to do is find the median. Luckily, they are already in order, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. That's an odd number, so there should be one number in the middle, and I'm sure you can see it is 17. That is our median. Now, for calculating the quartiles, we basically need to ignore this median and find the median of the lower and top half, okay? So we need to find the median of these 4 numbers, not these 5 numbers, okay? That's important. You need to exclude the median, otherwise you're going to get it wrong. So lower half, we have 4 numbers. So the median is going to be right here between 14 and 16. So it'll be 15. And up here, our middle is between 19 and 19. So it's just 19. All right, we call this the first quartile. The median is called the second quartile, and this is called the third quartile. All right, the fourth quartile will just be the top of the data set. Okay, so for our 5-number summary, we need 2 more numbers. We need the what's called the lower and the upper extreme, just means the smallest and largest number in the data set. So now for our 5-number summary, we just write 11, 15, 17, 19, 20. Okay, lowest score, lower quartile, median, upper quartile, and highest score. Okay, simple as that. And now for the IQR, the interquartile range, that's just the distance from Q3 to Q1. So it's just from 15 to 19, which is 4. And now for our box plot, you should have seen these before. They look like this. So we have our first and third quartile and median as as vertical lines, and we form a box around those two. And then we just draw lines stretching up to the upper and lower extreme, and there is your box plot, okay? So this box in the middle should contain the middle 50% of the data, okay? Because it's from the first quartile to the third quartile. So it's got 2 quarters, so this is 50%, and the lines also represent 50%. Okay, these box plots can give you an idea of how symmetric or how skewed your distribution is, whether it's heavy in the middle or heavy on the ends. So it just gives you a good idea of how spread out it is, really. All right, next example, we have a cumulative frequency histogram down below. So we have cumulative frequency, we have an ogive, aka polygon. We're going to find these 4 measures. We're going to start off with the range, okay? Range is nice and easy. It's just the highest score minus the lowest score, which is not 40 minus 0. The highest score is 7, and the lowest score is 2. So we just need to do 7 minus 2 and get an answer of 5. Okay, piece of cake. For the next one, we're finding the interquartile range, so we've got to find our quartiles. This one's got a little bit of a trick to it. Okay, so first of all, we've got to think about our median. So if there's 40 scores in total, which is why these cumulative frequency histograms are good for this kind of question. If there's 40 scores, that means we'll have the halfway point being around 20. Okay, so our median is going to be about 3. And now we find the middle of the top half and the middle of the bottom half. So it's going to be around 30 and around 10. So if we draw horizontal lines from these and we see where they hit the ogive, so the first quartile is going to be in the 2, the median is going to be in the 3. Now for the upper quartile, it hits the red line right on the corner between 4 and 5. So you got to think to yourself, is it going to be 4 or is it going to be 5? I want you to have a think. If you said 4, you are wrong. If you said 5, congratulations, you are also wrong. The answer is actually 4.5, okay? Because this is basically saying that the 30th score is a 4, but the 31st score is a 5, all right? So if you think about this data set of 40, the median is not really going to be the 20th score. It's going to be between the 20th and the 21st, okay? Because it's an even number. There isn't 1 in the middle. There's 2 in the middle, the 20th and the 21st, okay? Likewise, this top half has 20 scores. So 10 is not the middle. The middle is between the 10th and the 11th. So it's between 30 and 31. Okay, and when those two scores are different, which they are, 4 and 5, you take the average, which in this case is 4.5. Okay, so just be careful. When the number you're looking for hits right on the corner, you've got to do the average of the two scores on either side. So our interquartile range is 4.5, take away 2, so we get 2.5. Okay, bit of a tricky one. Next up, we're going to find the 8th decile of this data set. So if we think a decile would split this set of 40 into 10 lots of 4. Okay, so the first decile would be the 4th score. The second decile would be the 8th, so on and so forth. So the 8th decile is going to be the 8/10ths of the set of 40. Okay, and 8/10ths of 40 is 32. So we are looking for the 32nd score. So we draw a line right about 32. We see it's clearly going to hit in 5. So that is our 8th decile, 5. Up there. And for the last one, we have the 35th percentile. So again, this splits the data set into hundredths, and we're trying to find the 35th hundredth. So we'll do 35 hundredths of 40 to see what number we're looking for. That works out to be 14, coincidentally. Nice even number. So now we just need to look for the 14th score, so about just below 15 here. We'll draw a horizontal line, and it's clearly going to hit in the 2, so that is your 35th percentile. 2. Okay, cool. Moving on. We're going to look at outliers now. So outliers are typically scores that are significantly bigger or significantly smaller than the rest of the data set. Okay, so there's usually a bit of a gap between them, but not always. It's important to identify outliers because they have a massive effect on statistics which calculate based off every score. So for example, the median is not really going to be affected by outliers because it just shifts at one spot. But the mean, which takes the sum of every score, is significantly impacted by outliers. So quite often in statistics, outliers are identified, and for the purposes of the mean, they're often ignored. So we need to know how to find them. In this course, we classify outliers as scores which are greater than the 3rd quartile plus 1.5 times the interquartile range. Okay, so if you find your 3rd quartile, find your interquartile range, and you compute this, it'll give you a number. And any score above this number will be defined as an outlier. Likewise, if you compute the 1st quartile, take away 1.5 lots of the interquartile range, you'll get a number. Any scores below that number are classified as outliers. Okay? Let's have a go using this concept. We have a pretty big data set, and we're going to figure out if there are any outliers. So just from looking at it, looks like a pretty even spread. Bit of a jump from 7 to 10, but then 10, 11, 11. It looks like if there is going to be an outlier, it's probably going to be the 19. Okay, so To check whether this is an outlier, we need to first of all find the quartiles. So how many scores we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which is an even number. So we'll have two halves of 9, and it'll be between the 9th and the 10th score. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's between these two guys. So 5.5. Okay, now we need the quartiles because we need to base this off our interquartile range. So we have 9 up here and 9 down here. 9 is an odd number, so there should be one score in the middle. So there'll be 4 and 4, and the 5th in the middle will be the quartile. So 1, 2, 3, 4. 4 is our lower quartile. 1, 2, 3, 4. 7 is our upper quartile. All right, so that means our interquartile range is 7 take away 4, so 3. And so now we're going to use that formula and see if any scores are greater than the third quartile plus 1.5 lots of the interquartile range of 3. So let's compute. We do 7 plus 1.5 lots of 3. We get an answer of 11.5. Okay? Which is interesting because it means that this 10, 11, and 11 are close to being outliers. If there was a 12 here, it wouldn't look like an outlier, but based on the maths, it would be. Okay? So anything greater than 11.5 is an outlier. So 19 definitely is an outlier, which means that it'd be appropriate to ignore it if we were going to find the mean or similar statistics. Okay, so if that makes sense, you can get started on the questions in 903 and 904. Try and complete a variety and try and see all the different types, and you'll be fine. So that's all from me. So thanks very much for watching, and I'll see you guys next time.